Yep. Okay. So, ladies and gentlemen, this model, longitudinal data on smoking history, implementation science elements, incorporates a couple things I want to show you. One is with respect to Dr. Yan's question earlier on having a transition that might be influenced, say, by the sojourn time of a previous state. So maybe how long it takes for us to be treated to the point of smear conversion for TB might depend on how long we were infected, or sorry, how long we had active infectious TB previously, so before we entered treatment. Now, this model doesn't incorporate precisely the same thing, but it's got a related thing, ladies and gentlemen. Particularly, it has a running total of years smoked, the number of years that they've been spent as a smoker, okay, and the number of years smoked before the current time smoking, okay? And the basic deal for accumulating those sort of longitudinal measures is a one that involves a few elements, but is pretty straightforward. So basically, when we initiate smoking, ladies and gentlemen, here, incidentally, we record the history. So this model records the history of smoking as well. So in this initiation, we record away the fact that we started smoking at a certain time. Now, when we enter into the smoking state here, ladies and gentlemen, if we enter into the smoking state, we record when did we start smoking? What's the current time? This is the entry action, so it occurs, it's triggered at the current time, okay? So we get it at the current time. And then, ladies and gentlemen, when we stop smoking, we basically will store away a running total of the years spent smoking by the duration of the current smoking episode in years. And that is simply computed by the current time minus the time when we came in. So basically, we come in here, we record when that is, and we remember it. And then when we leave, we take the difference between the current time and when we came in, and we use that as the duration of the current smoking episode in years. So this basic mechanism could be adapted very readily to address Dr. Yan's question, which is rather than having a running total, a cumulative total of how long we've been smoking, whenever we leave the current smoking state, we could just record the difference between the current time and the time when we entered. Because we remembered when we entered in a certain variable. Remember, variables are for quantities that change over time. And a variable here will be like the most time of last initiation or relapse, the time I last became a current smoker. We'll remember that, and when we leave, we'll make use of that information, and we could very readily assign to a variable the difference in the current time and the time when we entered and make that the last sojourn time, prior to entering a certain state. Okay?
Yeah. Another complication.
Yeah.
What if this hazard depends on two time scales? One is the sojourn time, the other is the natural chronological time.
Mm-hmm.
For example, if I talk about long-term like HIV or hepatitis, it's a last a long time.
Yeah.
And then each transition, the hazard may depend on the sojourn time itself.
Yes.
But also depend on the external time,
yeah.
such as be it education intervention, they modify their hazard on the external time.
Yeah. So I can imagine. It's a great question. I can imagine three sort of sets of times. The last sojourn time, the time that I've spent in this state. So we know HIV, for example, has these stages of acute infection and long-term latent infection, et cetera. And so there's some time I've spent with HIV, and then there may be external factors in the external world, interventions or changes in regimen of ARVs administered, etc., which are affecting me as well. And all three of those could be readily captured. What you would have to do, and you see it here, is you'd have to have one of these transitions that tells it to recalculate the hazard periodically. Remember we put this in place yesterday? Do you remember this transition? We had it yesterday to recalculate that hazard. I'll just go and remind you. It was the model we built in the morning, and to capture the fact that it was this one here. Do you remember we put in place, oh sorry, this one here. We put in place this little thing. Do you remember that? Yeah. It's because the hazard rate was changing over time. We needed it to kind of wake up every, pick your time scale, every 1 week, 1 month, 1 year, and recalculate this hazard rate. So it would be with the case you're mentioning, Dr. Yan, with recalculating this hazard rate. But it could be very readily accomplished that you'd have all three timescales. To be clear, yesterday we had some cases, and in fact I might even be able to find them in here, where we had things at the person level referring to things at the main in Maine. An example was the model we built in the afternoon yesterday. We had a reference to certain parameters which were in Maine. I don't know if you remember this. We had to build this one on double time, but for example, this guy here, the timeout associated with him, you referred to Maine duration. That's because this parameter lived in Maine, this parameter here, okay? And so it is if we were dealing with factors in the overall environment, Dr. Yen, on things like treatment regimens that are currently in place, or the antiretroviral cocktails that are used for HIV and Hep C or whatever, you'd probably be connecting some of this dynamics up with information maintained in Maine about that policy or the regulatory or medical clinical environment. But at the same time, you would have variables that would keep track of your sojourn time in the last state, and then you'd be basically recording in just the same way you did here. You recorded when you entered what time it was. You do that for your current state, and you'd have to compute the time in the current state. You take the current time minus that time you entered. That would be your time in the current state, and that might also factor into a hazard rate, because generally hazard rates are time varying with the time since the start, the time without the event occurring. So you could very readily do it, and if you are interested, that's something that Winchell could probably mock up for you, this afternoon, and could build a little model for that, if you are interested. So, okay, ladies and gentlemen, a few other features of the model. This model does have, in terms of this re-entry, this model has a initiation hazard that's age specific. So we know that starting to smoke is the timing of initiation exhibits it's far from uniform over the age course, over the life course. It's predominantly concentrated in teenage years, although in certain ethnic groups, African Americans, for example, perhaps African Canadians, I'm not sure, it tends to be in the early 20s. And the point is that it's not a fixed hazard. It's an age-specific hazard. So I have age being calculated here. Now I further have here, by virtue of supporting these number of years smoked and time since quit in years, we have this hazard rate to heart disease being calculated by heart disease hazard. And the heart disease hazard here is calculated based on a baseline hazard rate for their age, for their current age. This is a baseline hazard rate for their age. Does anyone remember what sort of thing did we use yesterday to look it up by age? We used it begins with a T. Table function. It was a table function. And you'll find that baseline hazard rate is a table function. In fact, it's right here. You may remember defining this yesterday. We defined a hazard function, and this is a hazard function by age. And ladies and gentlemen, this heart disease hazard calculates a baseline hazard value, and then it calculates a hazard coefficient based on the years smoked, and a hazard coefficient based on the current smoking status, okay? And then we multiply the baseline by the one based the baseline here based on we multiply by a hazard rate coefficient for years smoked and for whether they're currently smoking, and that yields a result. One of the reasons I emphasize this, in addition to that type 2 diabetes model, because, well, I do a tremendous amount of work with competing risks, recurrent event analysis, and to a lesser degree pure survival analysis, although that's simpler in many ways. That's also something I'll readily undertake. And often the types of relationships you get out of a competing risks analysis or a survival analysis or recurrent events analysis can be placed more or less directly into any logic state charts in terms of the formulas for the hazard rates. And what I've tried to do here is provide some examples of the sort of relationships we'll get out of a competing risks analysis or survival analysis where we have some covariate, like years smoked, and then we have some beta for that covariate. And we have some hazard rate that's a composite of some baseline hazard function, which depends on age, and these various covariates. And that's a very comfortable form for those who work in that area of survival analysis. So anyway, this is an example of how the two come together. Mortality is also simulated, and there's a mortality hazard that depends on history characteristics as well. So we have a mortality hazard that depends on associated with heart disease and someone's age. Okay. Now, one notable feature of this model is that I alluded to earlier, but it's worth emphasizing, ladies and gentlemen, when you do have rates going on here, I do record events. So I record life course events for these individuals. And that allows us to build up a biography of these individuals. One of the features of ModGen, I must say I admire very much, and I credit Michael Wolfson and Steve Gribble and others for building this, is they have a bio browser, which allows you to browse people's histories. Now, we've built similar functionality for AnyLogic. So we built our own little bio browser, but it's not, at this point, I'm not aware that it's built in. AnyLogic's going this direction. Winchell, you've downloaded 7.3. Does it have a bio browser or some ability to browse individual level event information? They're planning to roll it out soon.
My understanding is that this functionality, as I see you in the previous,
It's in the database?
probably happens. Like, you can see the things in two different places. Like, without logging all the events into the database, you can see it from a event viewer, which is provided in, as I understand,
Yeah.
AnyLogic professional version.
Okay.
Probably also in the advanced user version, but I'm not quite sure about
Okay.
that. But
Yeah.
and as a workaround, what you can do is you can log all the events into the database to take advantage of the AnyLogic newly
Right.
incorporated database functionality. And in that case, you can see all the events that happens.
Okay. So, and can you view it for a particular individual?
Yes, basically
Yes.
all the events. And
Okay.
then all you do is just you do a query, and
Yeah.
you can
You could say, I want to see these events where they entered this state,
Right.
or where they received
Whatever.
this message, or where they were created.
yes.
Yeah.
You can even join the page.
Okay, that's something we've been really pushing them on for a couple of years, so it's great to hear they've rolled that out. And it's for health, by the way. We've been really pushing on health-related
Sure.
factors,
So
yeah.
the database then, is that viewed within any logic?
Yeah, yeah.
So what, using an SQL?
Winchell can show it to you, but
Sure.
I think there's some sort of query interface. I'm less familiar with it at this point, because in version 7.2, the database was, yeah, it was not everything we were hoping it would be, but it sounds like it's offering some good features.
Good.
Yeah. Okay. Anyway, these are some features of this model. Okay. Another thing that sometimes is useful, although less so. I think AnyLogic 7.1 and above may now offer automatically IDs of agents, but this model does show you how you could label each agent by unique ID, and rather than by counting on what their position is in the population, we label them by their some unique identifier, which might then be saved in the database. So we could have a history of their biographies in the database indexed by that ID. And that's a useful thing. We'll have people inserted in the database with a certain ID. Winchell, can you comment on that?
I think perhaps the function to get the ID of the agent is come along with, and surely already come with the database.
With the database, okay, yeah.
Yeah.
Okay, good. Okay, so this was a little model on smoking history, which illustrates recording events, keeping track of cumulative time and states, time-varying hazards, and some biostatistically inspired relationships in the model. Any questions related to that? Oh, by the way, and this does capture features of smoking, like this annual relapse hazard in years. Just like Dr. Yan was saying, often you'll have some interest in having a relationship that is based on how long I've spent in this state, not only in a previous state, but in this state. And this does have that. Your chance of relapsing depends on how long you've been a former smoker. So if you've only been a former smoker for 1 week, someone says, I've quit, I've ceased smoking, you got to take it with a big grain of salt. And in fact, I did my first work in health policy area, in fact, with cost effectiveness analysis, using dynamic models about 17, 18 years ago. And I was working in the smoking area, and it was really heart-wrenching to see, because if you look at the statistics on quit attempts and so on, it's almost Sisyphusian. People try to quit, and then they roll back, and they quit. And in the course of a year, they might try to quit 6 times, and it really moves one to see that. And this captures the fact that, if you're quit for just a short time, you have a very high chance of relapse. But if you can stay quit by hook or crook, I remember reading about one guy who asked to be dropped off in an island or something, and he had no access to cigarettes for 3 months or something like that. If you can get to that place where your body's addiction is less central, your psychological conditioning is better, then your chance of relapsing on a per week or per month basis is much lower. And so this captures this decrease in relapse, which has been documented, as I recall, nicely in a Surgeon General's report from a number of years back.
I suspect it probably doesn't go to zero. My wife, who has not smoked in 45 years, occasionally will, it'll come up.
The craving.
For whatever reason, yeah.
Yeah.
Even after 45 years.
Wow.
Many people have told me, you're always a smoker, you're just not smoking.
Yeah.
You're in remission.
Yeah, and as I think, it may have been the Surgeon General's report which discussed this, there's probably several factors involved, right? There's people learn there's physiological factors, but then there's psychological factors, and there's learning how do you talk yourself out of getting a cigarette. How do you, you'll give yourself 3 ice cream cones, today if you don't take that cigarette, and you learn ways to kind of manage your impulses in that regard. And that also may decrease your chance of falling back into it, even though it's not, a biologically sort of pathway sort of issue. Okay. Anyway, this model is perhaps a useful reference one as well. Okay. I would note that I did my first modeling in the tobacco policy area using compartmental models, and I'm a big believer in compartmental models for a lot of our work. We use them extensively. But I did feel at a certain point I was in a straitjacket with compartmental models for representing certain types of effects. And when I built up this model for fun, I decided, I really want to use it to do justice to some of the factors that I didn't see, that I couldn't capture easily in a compartmental context. It doesn't capture all of them. I mean, one thing is I'd like to go back to this model and capture social network effects, for example.
Oh, yeah.
Now, and I'm trying to remember this initiation hazard by age here. This is just a fixed thing. Really, I'd like to put in, and I do have many other models where you have social network impacts on physical activity and so on. And I should really build that up here. But it's a model that, for me, has some emotional significance just because it captures some features I always felt I really couldn't capture that well in a compartmental context. Okay, so that was longitudinal data on history, longitudinal data on history of smoking. I'd like now to go to a hybrid model. So if you can find this one in, maybe I'll do this.